Hey, in the previous video, we started creating our weather app and finished the layout using React and Tailwind. Today, we'll complete the app by making it dynamic, allowing it to retrieve real-time weather information for any city and even the current location. So, let's get started. To retrieve real-time data, we'll use WeatherAPI, which provides accurate weather information for any location worldwide. An API, or Application Programming Interface, allows different systems to communicate. In our app, we'll send requests to WeatherAPI, and it will return data like temperature and humidity in JSON format, which we'll use to display weather info for any city or the user's current location. To use WeatherAPI, first create a new account by clicking Sign Up. After completing the sign-up process, log into your account and you'll be taken to the dashboard. Here you'll find your API key. Just copy it because we'll need it for our app to fetch the weather data. Okay, so now just add a const here, let's call it API key, and put your API key inside it. Then we'll start fetching our data. Go to the WeatherAPI official docs, click on docs space, and look for the request URL. In this case, you can copy it and create another const like this. Const API URL equals copied URL here. Since the API method we're using is forecast, make sure to add /forecast.json to your URL. Now the idea is, when the user types a city and presses enter, the data should be fetched for the given city or location. Let's implement that. Add an onKeyUp prop to the search input, and use a function, let's call it handle key press. This function will do one thing. If the key pressed is enter, it will fetch the data. So the function takes an event as an argument, and if event.key equals enter, it will call another function, fetch data. Let's create that fetch data function, and inside it, we'll write the logic for fetching the weather info. Normally, for fetching data, we use Axios. Axios is a promise-based HTTP client for making API requests. First, we need to install it. So open your terminal and type npm install Axios. Now to fetch the data, we need to import Axios. So at the top of your file, write import Axios from Axios. Inside our function, Axios works best when you write your fetching code inside a try-catch block. This helps handle errors smoothly. So let's do that. Inside the try block, we'll create a variable, let's call it response, that will store the result of the API call. Const response equals await axios.get. Don't forget to make your function async, because we're using await. This ensures the function waits for the data before continuing, otherwise it might return before the data is ready. Now inside axios.get, we need to pass our API URL. But remember, the URL still needs query parameters. You can check the WeatherAPI documentation for a full list of available parameters. Here's what we need. Key equals your API key equals the query, city or location name. Days equals number of forecast days. Let's hardcode a test example first. After the URL, add key, AP key, Q equals Madrid, and let's consider days equals 1. After that, let's print the response to the console to check the result, console.log response. And in the catch block, if there's an error, like the city isn't found, we'll log a message, console.log, there was an error or the city was not found. Now save everything, open the browser's console, and click the search button to test it. Type test and click enter and oops, as you can see, the response is printed here in the console. Let's take a look at what it looks like. It contains a few things. As you see here, we have status with value 200, which means the request was successful. Status text is okay. But the most important part is the data object, which contains the forecast information. To make that clean and visible, let's log just the response data. So go back to the code, and instead of console.log response, update it to console.log response.data. Now let's test it again. Clear the console, hit enter, and as you can see, the response data is printed here. Let's parse it now. First, we have the current object. Open it. It contains last updated, which is the last updated time. Inside current, there's also a condition object, which contains text, like clear in this case, and icon, an image representing the weather condition. Still in current, we have temp C, which is the current temperature in Celsius. Then we have the forecast object, which contains a forecast day array with detailed forecast info. Finally, we have the location object, which holds location details like name, e.g. Madrid, region, country, e.g. Spain, and other info like latitude, longitude, and local time. So this is pretty nice and well structured. Now let's see how we can display this in our UI. So to display the response data in our UI, we need to create a state. Let's call it weather data. Define weather data and set weather data using the useState hook, and initialize it with an empty array. This state will be used to store the weather data. Then, go to your fetch data function, and after the console.log, use set weather data to store the response data. Here we need 4 things: the location name, the icon, the temperature, and the status description. As we saw, the location name is present in the location object under the name property, so remove the static Madrid and replace it with weatherdata.location.name. For the icon, we also need to modify the src attribute and set it to weatherdata.current.condition.icon. The temperature is available in weatherdata.current.tempc. And finally, the status description text is in weatherdata.current.condition.text. So let's test that. Let's go to the browser, and oops, there's an error. The error says that weatherdata.location is undefined. Yeah, this is happening because weather data is initially empty. To fill it, we need to fetch data first. This happens because React tries to render the component before the data has been fetched and set. Since weather data is empty at first, trying to access weatherdata.location results in an error because there's no location property yet. To fix this, let's add a condition to only show the weather information if data has been successfully fetched. That means we'll render the information elements only when weather data is not empty. So go back to the code and wrap the information elements in a condition like weather data, NN. This way, the code inside will only run if weather data is defined and contains data. So let's see now. The error still isn't fixed. Let's double check what's going on. Here's the issue. In the useState, we initialized weather data as an array, but actually the data we're expecting is an object. So when React renders and tries to access weatherdata.location.name, it throws an error, because it's trying to read .location from an empty array, which doesn't have that property. To fix this, we need to initialize weather data with null instead of an empty array. This way, we can safely check if it exists before trying to access its properties. Now let's try it again, and yes, it works. Let's type a city name, Paris for example. It works perfectly. You can see the icons and location name displayed. Right now, it's still showing the weather details for Madrid. That's because in the API URL, we hard-coded q=Madrid as the query. So now, let's make the query reflect the city typed by the user. In other words, let's make the app fetch the weather for the city the user enters. To do that, first add a new state called city. So define it like this: const city set city equals useState, just an empty string by default. Next, go to the input field and set it up to track the user's input. Add an onChange event, and inside it, use setCity e.target.value to update the state with the type text. Also, don't forget to add valuable city to the input so it stays in sync. Now that we're storing the city name, we can plug it into the query URL in the fetch data function. So instead of hard-coding a city like Madrid, just use the city variable in your API URL. Let's test it now. Try typing Rome, for example. And as you can see, it works perfectly. The app now fetches and displays the weather for whatever city the user types. Now let's move on to the hourly forecast part. Just like we displayed the location name, icon, temperature, and description text, we can do the same with the hourly forecast. First, if you remember, the response data contains an object called forecast. Let's take a look at it. Go to your console.log and add response.data.forecast. Then check the browser and click Enter. As you can see, the forecast object contains a forecast day array. Inside that, there's an object at index 0, and within that object there's a day object. But what's really important for us is the hour array. It has a length of 24, one entry for each hour of the next day. To make this even clearer, go back to the code and print response.data.forecast.forecastday0.hour. Now, when you test it, you'll see it logs the full array of hourly conditions. From this array, we're interested in just 3 things for each hour. The hour, which is found in the time key, the icon, found in condition.icon, the temperature, which is in temp.c. So now we'll map over this array and display those conditions in the UI. To do that, we need to pass the hourly conditions to the hourly forecast component. So add a prop called hourly data and pass in weatherdata.forecast.forecastday0.hour. Now go to the hourly forecast component and receive the data from props. Let's add the prop there. As you can see, there are static hour boxes. Delete them all except one to use as a template, and then use a .map to render the rest dynamically. Okay, so now let's write hourly data.map. We'll call each object hour and also get the index. Since hourly data is an array containing many objects, we'll map through them one by one. For each one, we'll return a box. So let's place this div inside the .map function. Now we need to put the real data. Let's start with the hour. As I said, the time is in hour.time, but it contains the full timestamp, not just the hour. To extract the hour, we'll use JavaScript's date class and call the getHours method. And as you can see, that fixes it. Next, we have the icon. It's inside hour.condition.icon. And the temperature is available in hour.temp.c. So it's done. You can test it. Type a city, for example, Tangier or London, and alright, it works. Just a few finishing touches to go. So now we still need to add the geolocation functionality to fetch the weather conditions for your current location. But before that, let's add some error handling. Let's add an area to display the error if it exists. First, add an error state, so const error set error equals useState, and make it an empty string by default. Then, let's add a paragraph to display the error message. We'll show it only if there's an error, just like we did with weather data. So type error and n, then a simple P that contains the error. Now, if you go to the browser, you won't see anything, of course, because there's no error. It's empty by default. Let's initialize it with some content like testing error just to see if it works. Now it shows up. Let's fix the styling. Make the text red by adding the Tailwind class textRed500, center it with text center, and add some margin on top with MT4. That's it. Now we want to display the real error. So remove the test content and keep it empty again by default. Go to the fetch data function. Here, when the data is fetched successfully, it means there's no error, so reset the error to empty using setError. Then in the catch block, instead of just logging the error in the console, let's set the error state with the message, there was an error or the city was not found. In that case, we should also reset weather data to null by calling setWeatherDayNull. Now to test that, let's simulate an error. For example, type an incorrect API key and go to the browser. That's it works. Amazing. Okay, now the error is showing successfully. Great. Now there's just one more thing to finish our app, adding a getCurrentLocation button. To do that, go to your button element and add an onClick event. In that event, call a function. Let's name it getCurrentLocation. Now let's define this function. So const getCurrentLocation equals. To retrieve the user's current location, we need to use the browser's Geolocation API. This is available through the built-in Navigator object. So first check if navigator.geolocation exists. That means the browser supports geolocation. If it does, print yes, geolocation is supported in the console. If not, meaning the browser doesn't support it, show a fallback message, like geolocation is not supported by this browser. So let's test that. Click the geolocation button. If geolocation is supported by the browser, you'll see a confirmation message in the console log saying geolocation is supported by this browser. Nice. Now back to the code. To get the current location, we use the method getCurrentPosition, which is part of navigator.geolocation. This method takes two arguments. Both are callback functions. The first one is called when the position is successfully retrieved. Inside this callback, we can access the user's coordinates. Let's define two constants, one for latitude and one for longitude, by extracting them from position.coords, and then print both to the console to confirm they're being captured correctly. The second callback handles errors, for example, when the user denies permission, or there's another issue. Instead of logging the error in the console, we'll set the error state and display a message like unable to retrieve location, or just use error.message directly. Also, if geolocation is not supported by the browser, instead of printing a message to the console, we'll use setError to show a clear message in the UI. For example, geolocation is not supported by your browser. Now let's test everything. Click the geolocation button. You'll get a prompt asking for location permission. First, test the scenario where the user denies access. As expected, an error message appears. This is coming from the second callback function. Perfect. Now try the second scenario, allow location access. If everything works, the coordinates should be printed in the console. But wait, they show as undefined? That likely means something went wrong. Let's take a closer look and debug what happened. I think the issue was that the returned coordinates needed to be named latitude and longitude. So let's fix that. Now, click the button and wait. Yes, it works. The coordinates are printed successfully. Great. So now we want to use those coordinates to fetch weather data. But how exactly? Well, if you remember, in our fetchData function, we previously passed a city name as the query. So let's go back to the WeatherAPI documentation and look at the query parameter format. Here, we can see that the API supports multiple query formats. It can be a city name or coordinates in the format of latitude and longitude. It can also accept a US zip code, a UK postcode, and other formats. That means we can use coordinates directly to fetch weather data. So let's return to the code. In the fetchData function, let's add an argument called query and replace the hard-coded QQL city with QQL query instead. Now, in the onKeyPress function, we'll call fetchData query by passing the city name as the query parameter. And in the getCurrentLocation function, once we retrieve the latitude and longitude, we'll define a variable like const query equals latitude, longitude, and pass that to fetchData query. That should do it. Let's test everything one more time. So let's click the geolocation button. There's an error showing. Wait a second. Checking. Yeah, I think I see the problem now. I remember. We had changed the AP key earlier to simulate an error. That's why it's not working right now. Let's fix it by restoring the correct API key. Just replace it back in the code. Now let's test it again. Hopefully it works. And here we go. Yes, it works. It successfully fetches the current location's weather conditions. Nice. But wait, there's still an error in the console. Each child in a list should have a unique key prop. Yep, that makes sense. This is happening in the map function for the hourly forecast. We forgot to assign a unique key to each element inside the map. So in the map function, let's fix that by adding a key equal index to each returned element. Using the index is fine for now since the list won't be reordered. Done. Let's check again. Yes, that fixed it. Everything is now working successfully. And that's it. We've successfully completed our React weather app. Let's do a quick final recap. You can search for any city. For example, try typing Lisbon and instantly see the current weather conditions. We've also added a smooth, scrollable hourly forecast that makes the UI more interactive and user-friendly. Plus, you can use geolocation to automatically fetch the weather for your current location. In this project, we learned how to work with the WeatherAPI, how to fetch and manage data in React, and how to build a clean, responsive interface using Tailwind CSS. If you found this tutorial helpful, don't forget to like and share. And if you'd like more tutorials like this, just type yes in the comments. Thanks for watching, and I'll see you in the next project.